I must say that the biggest risk of shift left adoption by organization is making the developers angry. This is the biggest security risk. It's like for security personnel working in a SOC. The worst kind of enemy is false positive. And basically for the same reason, it's the biggest risk of actually making the solution work. It's not just about the false positive, it's about making the developers mad.
Welcome to the Head of the Breach podcast, where we talk everything offensive security. I'm your host, Casey Camilleri, and today on the podcast, we have Eyal Paz. Eyal is the head of VP of Research at Ox Security, a leader in software supply chain security. His work includes hands-on security research towards a holistic DevSecOps solution. Eyal has spent 11 years at Checkpoint, working on security research for product innovation and application security, malware analysis, and phishing prevention. Eyal is also a sought-after speaker at conferences like Black Hat and RSA on various cybersecurity topics, and is currently working on his PhD in researching the problem of encrypted traffic classification. Eyal, welcome to the Head of the Breach podcast.
Thank you. Thanks for having me.
What is the role of DevSecOps?
So DevSecOps is pretty new. Until 5-6 years ago, DevOps was not like a phrase as well. So DevSecOps, it's a variation of DevOps, basically bringing the security side into the DevOps software lifecycle.
What would be like the day-to-day activities one would do if they're working in DevSecOps?
So if the traditional DevOps, if you can call it traditional, because again, this is a new paradigm as well. So the DevOps are responsible for having for making the developers' life easy, shipping new software to production. So the DevSecOps is basically the same thing, but with respect of security. So keeping the same pace of rapid development, shipping like real business value really, really fast for growing the business, but keeping also the business without all of the risks involved from the cyber landscape.
Is that kind of that shift left movement that we hear people talking about?
So shift left is a big deal in DevSecOps, because when people start to playing around with DevSecOps, they realize that if they will wait until the application will be already deployed in production, then it's going to be very, very hard to actually be good on their job and keeping the business secure. So the shift left movement basically is DevSecOps bringing more capabilities to make their life easier and keeping the business secure by detecting the vulnerabilities before they reach production, where it's much cheaper to handle, and you don't need to get the penetration test or the bug bounty report, and because you're already covered because you prevented from this vulnerable code to be deployed from the first place.
Yeah, I would maybe argue you still want the vulnerability and penetration tests just to make sure you have coverage, but the actual shift left, I mean, you mentioned something that I think a lot of our listeners should perk up on is it reduces cost, right? Like you have the opportunity to reduce cost and reduce waste in your organization.
Yes, and I completely agree, by the way. There's no argument there that penetration tests will always going to have a room, like the human in the loop.
Yep.
Also, I think like after people will be out of jobs with all of the AI or taking over, I think the last people on earth with jobs are going to be penetration testers. So definitely not the kind of population that I want to make angry with me. However, like some of the use cases that I've got to discuss with some of our customers, when basically I'm working on this kind of shift left technology. So what we find out is that sometimes our customers actually ship or start the penetration test process before they are shipping new services to production. Actually, this is the way that this should be, like for new services to run the pen test on top of staging and not on top of production. And so we had this use case where they came to the development team and told them, hey, the penetration test found this and this kind of vulnerabilities within your product. And they say, don't worry, we already got it covered. Because they also in parallel saw that our scan detected this kind of vulnerability. So they already remediate it before the product was shipped to production. So basically, this is the classical way where penetration test and shift left approach actually mingle very, very well together.
Yeah, definitely. So let's talk about that, because a lot of our listeners are going to have, various degrees of shift left momentum, I should say, various degrees of pipeline. Some will have this already implemented, others will be just starting. And let's talk all through that. So if I were to kind of say, I want to bring shift left into my organization, I have applications that we're developing, I need more security testing, earlier in the process, where do I start implementing?
There is a wide of opinion in that landscape. I will just name drop a couple of places where technologies that are in use in the industry at the moment. So there is pipeline scan, or blocking merge requests or pull requests into the main branch. So I think this is a good way to go. For some organization, they found that this is also too late for them, and they want to bring it even more left. So there are also technologies.
So is that similar to blocking the commit or blocking the push because there's some sort of detection in some sort of flaw detected in the security in the coding?
Yeah. So maybe we should also discuss what exactly the kind of scanning that I'm talking about, because I'm jumped into the notion of scanning, but I didn't really make a dive through of what is a scan.
Sure, let's start there. Yeah.
So the kind of scanning that are involved within the shift left process. So there are mostly static code analysis scans, which involve SaaS technology of basically finding vulnerabilities within the code. And there's also a software composition, or also known as SCA, meaning that new dependencies introduced into the development project are also getting analyzed. There are also secret scanning to find some hard-coded tokens or PII information, which is hard-coded into the code, or also and more contextualized or policy-based kind of detections, like new APIs or some kind of Easter eggs that should not really be within the code. So these kind of scans basically are the scans that today are involved within the shift left domain. Now, there are multiple ways to implement this kind of shift left. You can implement the shift left within a blocking or scanning, and if needed, also to block merge request or pull request into a feature branch or into the default branch, main branch, or whatever. You can also take it a step even more to the left. You can run it as a pre-commit hook, so that any commit that the developer does before it's even reached the source control management system, like GitHub, Bitbucket, GitLab, etc. So if you implement it as a pre-commit, it's like the first line before it's reached any kind of system. So if you consider stuff like hard-coded credentials, tokens, secrets, etc., then this approach is safer, because the data is never transmitted outside of the developer's workstation. There's also a paradigm of actually integrating this kind of capabilities before the commit as well, like as a part of the IDE, as an IDE extension. So, but from my experience, this is where the frictions begin to be. It's too much for the developers to handle. Now, this is debatable. I started my career also as a developer, and I still doing some active development myself. And I know if there's something that I really hate, and my colleagues as well, is that someone's like the IDE giving this kind of yellow marker on my code and make my beautiful code very dirty. And this is like the typical kind of developers who are really, really in love in their code. So I personally, it's not my cup of tea to make this also imply into organization as a part of the shift left strategy, but it's definitely a trend that I know that people are talking about.
Yeah. Is AI helping that become less intrusive and more a better experience for the developer? Because it sounds like in the past year we've made a lot of changes. So I'm curious to hear your thoughts on this. But I like that you said that, as a developer, it basically kind of muddled with your user experience of developing good quality code. Is that because it wasn't accurate? Is it because it wasn't smart enough? It just always got in the way, slowed you down, and has that improved at all?
So I must say that the biggest risk of shift left adoption by organization is making the developers angry. Like this is the biggest security risk. It's like for security personnel working in a SOC. The worst kind of enemy is false positive. And basically for the same reason, it's the biggest risk of actually making the solution work. It's not just about the false positive, it's about making the developers mad. And this could be for numerous reasons. For example, if you are integrating within the pipeline, but you integrate some kind of like an open source product or whatever in the pipeline, it's taking forever to run a scan. So this is going to make the developer really, really angry. You need it to work fast. You need it to be like seamless for the developer. Like if it's all good, then all the developer wants is to have is code deployed on the development server or staging or production or whatever, so we can verify that it's work not just on his machine but also on the development cluster or whatever the deployment target is. But if the pipeline is taking too long, this creates friction. And same goes for the pre-commit, as I said earlier. Now for the IDE, this is where it becomes personal, because like the developer workstation, this is a big no-no for my expense. But again, I know that for some organization, they really, really put it on the top of their head that this is the most important thing to have in their shift left strategy. And I respect it. I just don't agree with it.
Yeah. Now let's talk about it. So now that you've clarified all the different types of scanning and different things that you can do, where do I start if I don't have much of this? Where do I get the best bang for my buck? I imagine I don't want to just try to muck with my developers at IDEs and make them angry, or even put a pre-hook in before I do some other things. Like, guide me. Where should I start? Where do I get the best bang for my buck?
Well, this is where DevSecOps and also the infrastructure engineering portion comes into play. When the entire experience of the shift left should really be seamless for the developers. It should be like very, very trivial for them to understand. And also when there is a real issue, then it should be very, very clear to them what they need to understand. Now, the way to get to it is gradual. You cannot do it in one day. So it's like when you are deploying a new security tool, and I know I'm coming from background. Before I came into AppSec, I worked in network security. And when you deploy like a new network security kind of solution, you never put it in prevent mode from day one. I'm not talking about the firewall, of course. I'm talking about like some kind of IDS versus IPS. You first like put your IPS in detect mode, as serving as IDS. You are seeing which kind of alerts you detect. You triage the alerts. You first see that you indeed get like what is the ratio of false positive, and is it and you measure what is the impact of this is now getting out, or this pipeline getting back to AppSec. What is the business risk of this alert, which I didn't prevent on, like I didn't block the pipeline, I let it through. What is the business risk that this brings to my organization? So after having few of those case studies, and again, in an organization, let's say in an organization of 100 developers, let's say there are a few dozen of such merge requests per day. So this process can actually be very, very fast. Like within a week, you can gather like pipeline scan results of hundreds of pipelines, and you can review the data, and following like the preliminary triage, bring in the development managers. And if you have security champions program in place, even better, bring them those as well, and review the findings, not from the eyes of you, like as a security guy, telling the development managers, look, your developers are really, really stupid. They know nothing about security. They putting all of those risks into our organization. But from educational point of view, look, this is why now we need to switch to block mode. We see that if we add block this in this week or 2 weeks or whatever, this kind of grace period, we would have prevented this and this vulnerabilities or secrets to leak out into our production environment. So I think basically, as I said, the biggest threat of shift left is making the developers angry. And the biggest thing that you can do into making the shift left actually work for your organization is convincing the development managers and the developers themselves that this is their interest to actually have this gate into place. And just like we have QA, which sometimes is annoying for developers, but once in a while they catch a bug which would like be very, very embarrassing for developers that it will be released. Same goes here. And same as developers are already accustomed to working with QA guys, so they should be accustomed to work with security guys.
So, Al, what could we do? Like, if for what I'm hearing is it really kind of depends on where you start in the organization. Start small, start small in the pipeline. But like, pretend I have code, I have test case, I have infrastructure as code, I have some of the basics down, but I'm just missing some security in that pipeline. Like, where should I start? Static code analysis, dynamic, like dependency, secret scanning, like where should I start?
So I suggest to start with the pain point. Like it's always the thing that people like developers would be most cooperative with is something that they recognize as bad. Meaning that if, for example, in some organization, there was a recent like crisis because of this kind of XSS on their production application, then they should be really, really sensitive about XSS. And the way to find XSS, for example, is integrating a code security tool like a SaaS tool into the pipeline. And that's it. XSS are really, really easy for SaaS tool to locate with very, very high precision. So like low risk of noise from that end. And I think like this would be a very, very good use case with very high success rates. Same example is like if for some organization, maybe a DevOps organization, by mistake put a Terraform code, which put some S3 bucket exposed out to the internet with some sensitive data. Now, and doesn't matter if it was found by penetration test or by a customer or by some random hacker. Basically now, all DevOps know this is very, very bad. And the way to solve this is by infrastructure as code scan integrated into their pipeline. So I think something that will also maximize the chance of success in this case is actually putting into play shift left scanning, which is relevant to something really bad which recently happened. Now, again, this is one kind of approach. If you didn't add any incident regarding application security in the past 2 years, of course, you can still integrate it. But what I'm saying is that security guys should really, really take advantage of bad things which happen to their organization as excuses to move forward with the shift left paradigm, because as mentioned, I think that this will have like developers and DevOps more cooperative into putting these technologies and also making them more patient for stuff like, okay, maybe this can put more time into their pipeline, or maybe that's false positive, but they will still be cool about it because they will know that this will solve the specific use case of this kind of leakage or vulnerability or any kind of embarrassing stuff going on in production.
Yeah, and that's extremely helpful. So the takeaway there is start with the most pain. So for our listeners out there, you probably should self-assess and say, where do we keep encountering the most pain from a security perspective as it relates to this, and kind of start working there to detect that. A lot of what you are talking about reminds me of security awareness training when it comes to phishing and social engineering, right? It's kind of like we know that these threats exist. We know that people contribute to these threats, so we want to train them to be better to reduce that. But we also need to implement technical controls whenever, because we know that wherever we rely on people, mistakes and oversights happen. So if you have the technical control in there to actually detect and actually preferably prevent it from happening, awesome. If it can't be prevented, can you at least detect it? So all of that kind of reminds me of it's a very similar problem, but in order to start implementing and start making that approach to that shift left movement, if you don't have anything in place, or you want to better improve what you do have in place, it's to ask yourself, what's the most pain here in my organization?
Yes, and this is, by the way, this is not a coincidence. As mentioned, I came originally from network security. I also spent a couple of years working on endpoint security and on phishing problems. And basically, and also this kind of industry really moved forward really fast in the last 20 years. And now today we have XDR, EDR, NDR, all of those. And now they're already talking about the next generation of this kind of UABA technology and all of those. But the application security industry basically remain dormant in the same duration. So as I made this switch to application security about 3 years ago, I was pretty amazed that the most basic kind of security capabilities was not exist in the application security. And the same concept that we all know about. No, so earlier I gave the example of the IDS versus IPS. This notion did not exist in application security. So basically, myself, as I'm also building a product, I took those kind of knowledge that everybody knows about. Everyone's working in a SOC, doing any kind of security and incident response knows about, and I'm just bringing it and integrating it into the application security world as well.
Yeah. And I can relate to that because that's where my background is from too, the network side as well. And that really struck a chord with me when you kind of said the IDS, IPS, it's like, that's a great way to be thinking about this. Now, what are the most common vulnerabilities that you see that are discovered? And I know that is kind of dependent upon the different applications and the things that you're writing on. And the answer can be, it depends. But from your perspective, you've seen a lot. What, after you have a robust, or I don't even know if I should say robust, but after you have some sort of, DevSecOps pipeline built with doing a number of different things, what are the most common vulnerabilities that that it keeps discovering over and over?
Okay, so I'm just making the separation between like you connecting on day one and you're scanning all of your current code base, and what's going on from this phase going on. So when people bring application security, the first time to really scan their dependencies and their entire code base, they find immediately like thousands or millions even of open source security vulnerabilities, because those are so common. There are certain like packages which of a specific versions with hundreds of vulnerabilities, and taking it also to the container level. So if you integrate a container scanning technology, as well, you're going to get thousands of CVEs jumping on just this one container. So combining all of those together, you easily get to millions of vulnerabilities. Now, this is the sheer amount of vulnerabilities.
It's noise.
And yeah, of course, most of them are just noise. For example, if I will now pull like a Python image out of Docker Hub or Node image, I will get dozens of vulnerabilities, even on the latest, like Debian or Alpine operating system. I will get dozens of CVEs, which are simply irrelevant for my application use case. So this is why in day one, you're probably going to get this sheer amount of open source security vulnerabilities. Now, I'm mentioning those separately because this is amount which puts a great shadow from the quantitative point of view of all of the other code security issues, secrets in code, infrastructure as code, for that are also going to be there, but from the quantity point of view, there are going to be much less of those. So obviously, in some organizations, they see this sheer amount of vulnerabilities. And of course, that most are going to be highly critical because according to the NVD, roughly, I think the statistics is 60% is either critical or high severity. So without any kind of sophisticated prioritization mechanism, basically, this is what you get in day one. Now, I'm mentioning that this is like day one because now start the process when you need to make a decision. Are we now going to deal with the backlog? Or are we now looking forward and starting the shift left approach and starting to prevent from new stuff to pile up? Now, my advice in these cases is first focus on the new stuff while trying to figure out what is the really, really important things that you can and should clean from your backlog. Because like many like scanning like your entire code base, maybe it's completely irrelevant because maybe there are a lot of like the pieces of code which are dead code, not deployed anywhere. Maybe it's like legacy code which is not in use. So I think from the shift left approach, to make it really, really, or from the application before shift left, from the application security point of view, to make the process works and create a good program, is to first to start and understand what are the actual assets that I need to protect. Again, similarly as in network security, to understand what I'm trying to protect. Following this kind of preliminary work of understanding what are the assets, then to put those kind of guardrails in place, starting to monitor and later prevent from new stuff to get in, while understanding the how to deal with the backlog.
Yeah, so kind of like at that, to use your analogy of IDS and IPS, right? It's kind of like you put the IDS in place, but like it just floods you with all the noise, right? And you gotta, will you ever get to the IPS, right? That's the goal, is to get to preventing. But if you just got so much noise, so much detection, you're gonna have a hard time making some movement.
Yeah, but the beautiful part, or the beautiful like differentiation in the analogies between IPS versus IDS and with pipelines, block versus detect, is that when you decide to block a connection, then you block the connection. Like there's no turning back because this is live traffic. Either it's malware traffic or it's an application traffic. You don't have like time to talk with the user, and it's also complicated. You're in a network layer. How will you create a discussion with the end user? In the development world, it's different because let's say that now I'm a security product. I'm detecting some kind of vulnerability within the current pull request. Then this is also the platform for communication. Like, and this is maybe also one of the most important thing in making the integration work and making by keeping the developers happy. Because also, if you pop up the block, like saying, okay, this is an alert and you want to block it. So having like the developer, the ability to override, I think this is also something that maybe like a step between a complete block mode. It's also like a good practice that can be implemented, because this way you are not blocking productivity over false positive. Like, because in the worst case scenario, the developers took 5 more minutes to verify that there's no security risk here. And then it can move on further with the pipeline. Now, again, these more complex policies obviously can be built on top of that. It can be built on layers, like some branches are allowed to override and some are not. But this is where like the more advanced kind of decision making comes for a more mature organization with shift left approach.
Now, should you build versus buy? Is there good open source tools out there that can contribute to the pipeline? Or do some of them fall short, and should you be thinking about buying a solution?
So let's think about it together. So obviously there is a lot of very, very high quality, well-maintained open source software out there now. And this is very, very easy to implement, by the way. Like defining a GitHub action or a GitLab CI job, which fail if, let's say you run an open source scanning tool like Gripe or Triving, and if it detects anything in the dependency scanning, then the tool return like a non-zero exit code, and then you can block the pipeline very easily if the pipeline ends with a non-zero exit code. This is like trivial to implement. Now the problem starts when it does find stuff. And now what do you do? Like, what do you do when things go wrong? So I think that open source usage, it's very, very good practice, either when you simply don't have a budget and you need to have something working. It's very good for experiments, for running experiments with, like, to assess what is like as a preparation toward like larger deployments, because again, it's free and it's very, very simple to implement. But I think that it's not manageable on larger organization and outside of like simple experiments. And I've encountered really, really large organization with very large security team. And I found it blew my mind when I understand the amount of time and the amount of effort that they took, and they built this amazing. It's an entire product. They built an entire product all based on open source software, and it works. But thinking about the amount of time it took them to actually to build this infrastructure and the size of the team, this is absurd, because they could have made much better use of their time and just getting a security product which is implementing basically the same kind of capabilities. It just does it a little better and obviously faster.
Yeah. So basically the same thing in business in general, right? You gotta outweigh the cost of whether you're going to build it, buy it, and time and money and everything.
Yes, but again, the temptation of taking on open source is big, because there are really, really good open source projects out there. But at the end, you need to make it scale. You need to have tickets on top of it. You need the entire process. And again, to make the shift left process work, you need a tool which actually can also integrate with your ticketing management system, with your messaging application, and all of those enterprise capabilities that you really, really don't want to implement yourself.
Yeah, you need the workflows, right? Because it's, so what if you just had a non-zero exit, right? But like, what do you do with that, right? And so you need to build a workflow around that, and a large enterprise is already going to have some of those workflows, so you need it to integrate.
Yeah, and coming back to the, again, I will really getting to the IDS example over and over again. But also when you add Snort, people still buy Sourcefire, like, because Snort was just not good enough.
Yep. What is an SBOM?
So until like 2 or 3 years ago, I think most people didn't knew the term at all. And a big thank for President Biden for making sure that everybody knows about SBOM and a big present to the security industry. So SBOM is an acronym for software bill of material. Basically, it's an inventory of all of the open source components that you use within your project or organization. It's actually not necessarily just open source, because if you are like using an SDK within your code, like if you pay for some other third party vendor for some, like it's maybe like a UI widget, I know this is a big deal today that a lot of organizations use and integrate this kind of third party software component. So you actually, their SBOM is also a part of your SBOM. And by a lot of regulations, you are also obliged, like you as an organization are obliged to also deliver your SBOM upon request. And so the SBOM basically contains the packages and versions of the software component which are in use. And this also includes their license and the current vulnerabilities, known vulnerabilities by the community. But putting aside regulations and executive orders and all of those, SBOM are the own organization interest to have, like to have the updated SBOM. Because when shit hits the fan, like when there is this log4 shell vulnerability, which when everybody is talking about, and it's a real deal. It's the real deal. Like you see live exploitation everywhere. Every firewall, every network devices see that these funny exploit attempts going around all over the place. Still today, by the way. So you need to, at day one, you need to make sure that you instantly know exactly where are the places in your code which are exposed to this vulnerability. And when the log4j incident happened, SBOM was not really well adopted, and people work like crazy trying to understand where this log4j vulnerable component is actually being used. And the big problem about it, and this is a big thing in SBOMs, that you need visibility not just for your direct dependencies, but also for your transitive dependencies. Because even if you have a dependency which uses another dependency of that, which uses another dependency, and these ones bring log4j into your ecosystem, then there's still the risk of active exploitation going on your production system.
Yeah. So, I mean, that's a good call out. You just can't look at the first line of dependencies. You need to look at dependencies of dependencies and actually walk the tree all the way down.
Yeah, so this was actually out of the research that I presented alongside with my colleague Liad Cohen at the recent Black Hat in Las Vegas, where we delve into research regarding what does it mean to actually to be able to exploit this kind of transitive vulnerabilities, because everybody understands, like, oh, it's very very easy to understand the likelihood of exploitation of direct dependencies, because basically direct dependencies are almost equivalent to your own code, because like when you import and actually use an open source dependency, well, there's a high chance that you are using a vulnerable component in a vulnerable way. But again, there's also some likelihood that you are using the package, but either you are using it on a safe way, not by actual secure design, just that you did not invoke the vulnerable code of the dependency. So basically, what we showed in our talk is that as you go deeper into the dependency graph, you will find that the chances of exploitation become astronomical. They still exist, but it's becoming astronomical. So this is also reference to what I said earlier when we discussed the sheer amount of the vulnerabilities, and also like the notion that most of them are simply irrelevant. And because roughly 70% of the vulnerabilities that we see like in the first scanning of an organization are actually transitive. However, not all transitive vulnerabilities are equally in their chances to actually be exploited in the wild. And the reason for that is think about the log4shell vulnerability. Basically, the main condition for exploitation of a vulnerable package was that a user tainted input. Like if you're running a web server, you need the input coming from external, like unsanitized user input to go through the entire chain and eventually to reach a log line, which is the most basic kind of usage of the log4j package. So in this specific case, it's actually the chances of exploitation are very, very high. Basically, this is the research that we did. We actually read this kind of classification of the different vulnerabilities type, and we saw that so not all vulnerabilities are actually alike.
Yeah, I remember the log4j very well, and it is one of those vulnerabilities where the exploitation was super easy, and to bypass, manipulate the exploitation, and bypass technical controls for a vulnerable system, it was super easy. But the actual discovery and hunting and finding where you have vulnerable instances was actually the hard part. And like you said, it was kind of before SBOM really blew up. And so a lot of organizations were scrambling. Some were lucky and they had it. But having that gets you out of that, oh, shit hit the fan. Now I'm scrambling to hunt, scan, and find this thing versus, oh no, I already have the shopping list. I know exactly where these things are at in the store, and boom, go. And you spend less time hunting, more time remediating.
Yeah, and SBOM really made it easy. And today it's commodity, like everybody have those, and whoever doesn't have it will be required by regulation very, very soon. So again, as it's becoming commodity, and again, there's also a lot of good open source software supporting this kind of capability. So if you don't have like a security product in place who is able to create this kind of SBOM, it's definitely one of the things that I really, really recommend. Just pick up the first open source that you see and just make it happen and have this kind of periodic SBOM in your organization.
Eyal, you've done a lot of research, such as, what was the name of that talk at Black Hat that you gave it to your colleague?
It was will we survive the transitive vulnerability logs?
Nice. So check that out. And then you also have some upcoming research that you'll be giving a talk at too. Where could our listeners find that research and that talk?
Yeah, so the next public appearance that I will have is again with Liad Cohen at the RSA conference in the end of April. So we are going to discuss our new research regarding 10 ways to get owned by GitHub. So basically, it's a continuation of our research, but now we are not just looking about the known transitive vulnerabilities or known vulnerabilities in open source, but actually there is a much greater attack surface, which is all hosted on our beloved GitHub. So in our research, we actually demonstrate 10 different ways. Some of them are really surprising. I was surprised doing the research regarding the things that we could very easily do on top of GitHub and how to abuse this system and the trust that people misplace in this system into creating a really, really amazing and mind-blowing exploitation.
That after that gets released, we should probably have you back on to continue that conversation about that, because as a red team over here, we abuse a lot of the pipeline and the actions and steal a lot of stuff from it. So it sounds like a whole other conversation that I'd love to have with you. But we're out of time today. So Eyal, thanks for joining us on the podcast. And if someone wanted to follow you and your research and the things that you're coming out with, how could they get in touch and stay updated with your work?
Well, I'm publish when I have interesting updates and thoughts. I'm sharing it on LinkedIn. This is my major social network. Other than that, I attend several conferences during the year, so you can find me. And again, if you are going to the next RSA, you can look me up. And that's it pretty much.
Eyal, thanks for joining the podcast.
Thanks for having me, Casey.